Hello everyone, my name is Dingren Wang and I'm here this semester to do a special project with FPGA video processing system. And this project is finished by a Z board, which is a Xilinx Zinc 7000 series FPGA device. And as we know that FPGAs are very good for image processing with regard with the power efficiency and the speed. So with this project we expect to do real-time image processing, and now I'm giving you a very short demonstration of this project to give you a big idea of this project. And this project is basically formed with three parts. The first part is the image acquisition from the camera, and you can see that here is an external camera that can capture the video to feed to the Z board. And the second part is the SoC on the FPGA, the Zinc 7000. And this part is to do a very simple video processing and to buffer the video data into the external DDR memory and read the data back and output to the monitor. And the third part is the output part, as I mentioned before, is use the HDMI transmitter to output the HD video to the monitor. And in the Zinc part, we use the VDMA, which is Video Direct Memory Access, to buffer the video into the. And this is the block diagram of this video system. And the camera is feeding the video into the Z board. And this first block is to pre-process the video to a format that the Z board can recognize. And the second part is the first VDMA block, which transfers the video data into the DDR memory. And there is another VDMA core that reads the data from the memory and outputs to the HDMI ports. And this is the brief achievements of this project. The first one is the establishment of the VDMA system, as I explained before. And the second is the camera and the video timing formatter, because the data format from the camera is in a very special mode. So this part is to reformat the data so that data can be recognized by the system. The third is to do the driver for the ADV7511 HDMI transmitter, which is the HDMI output chip, because this uses the chip to transmit the data, the video signal to the monitor. So this chip needs to be configured. So I wrote the driver for the chip. And the fourth part is the same to configure the camera with the driver. And the fifth part is to do the color converter from the YCbCr444 format to YCbCr422 format, because the ADV7511 chip recognizes only the YCbCr422 data mode. So we need to do the color conversion in this part. And the most challenging part in this project is the video formatting, because there is only 8 bits of the video data from the camera that inputs to the Z board. But for each pixel, we need at least 16 bits to represent 3 color components. So the only mode that we can choose from is the RGB 565 mode. In this special case, that it takes 2 bytes in 2 clock cycles to transfer 1 single pixel. So the first job for the video formatting is to convert this 2 clock cycle pixel into 1 clock cycle. So we have to map this RGB 565 video data into RGB 888 data format that is the most common seen RGB format. And due to we have to move the 2 clock cycle video data into 1 clock cycle, so the other synchronization signal which is H reference is it used to be continuous because each clock cycle, the data from each clock cycle are valid. But the present case is if we convert to RGB 888, there will be one gapping from every 2 clock cycle. So for the IP core, the video into axis 4, we cannot directly use that IP core. So we have to change the IP core so that can correctly recognize when is the end of line and when is the start of frame. To correctly configure the ADV7511 chip, we have to know the right I2C sequence to write the control registers, because the writing sequence for the register on the chip is very special. So I have listed several the documentation from the chip that can help you understand how to configure the chip. But the more details you can read from my report. As you can see from the monitor, that the camera is correctly capturing the video, and the system is doing the real-time output to the monitor, and all the color is correct, and it shows that the color conversion part is working, and the video MA is working, and the camera and the ADV7511 chip is working. So that's pretty much is my project this semester, and thank you for watching.